All right, so in this video, I want to sketch a couple of piecewise functions. So there's two tricks to sketching piecewise functions. The first one is you need to know how to sketch each individual function. And then the second trick is to just use the key point over here. Okay, so let's take a look at these two functions. Let's just sketch them individually first. So if I have f of x equals to 2, that's just a horizontal line at y equals to 2. So that's what that first function looks like. And if I have f of x equals to 3x, I know that this is a function with a slope of 3 and a y-intercept of 0. So it's a pretty steep line, passes through the origin. Just looks like that. Now I want to combine these two functions to create the piecewise function over here. So here's the trick. When you start drawing your piecewise function, the first thing you want to do is you want to label the key x point, which is 1 in this case. Then for the first function, x is less than 1, so it's the left side of 1, and the y value is going to be 2 over here because it's 2 on this entire thing. So I'm going to put an empty circle at y equals to 2 because there's no equal sign over there. And then it's just a horizontal line going to the left. 3x is the right side of the function. So if I sub in 1 into 3x, 3 times 1 is positive 3, which will be slightly higher than this. And there's an equal sign. So I'm going to put a filled dot over here. And then I know that this line just has a slope of positive 3. So it just looks like that. And that's how you sketch a piecewise function. You can label the y values here. This is a y value of 2, and this is a y value of 3. Now you can tell that these two functions do not touch each other, which means that the function is discontinuous at x equals to 1. Let's take a look at the next example. My first function is y equals to negative 2x. So this is passing through the origin, again, a linear function with a slope of negative 2. So negative means it's going in the opposite direction. That's actually positive 2. Oops. Negative 2 means it's going like this. And then our second function is x plus 4, which is again a linear function with a slope of 1, but a y-intercept of 4. So it looks like that. Again, I need to combine the two functions. The key point in this case is at 0. So if I sub in a 0 into my first function, negative 2 times 0 is just a 0, which is basically the origin. And then this is less than, so I want to put an empty dot over here. And then I want to draw this going on the left side, which is just this part over here. It's got a slope of negative 2 there. For the other function, 0 plus 4 is just positive 4. And then we want to draw the right side of this function because it's greater than equals. I'll put in a fill dot because it's equals. And it's just going to have a slope of 1. And again, these two functions are not touching, so it's discontinuous at x equals 0. Let's look at the third and final example. We have an absolute function over here. We know absolute functions are just a V shape. This is a basic absolute function, so it's at the origin. It just looks like that. And then I have negative x squared. Negative x squared is just a quadratic function, but it opens downwards. Again, it's going to have the vertex at the origin because there's no shifts. So let's start with our piecewise function now. I know that my key point over here is negative 2. If I sub in negative 2 in the first function, I'm going to get a y value of positive 2. And there's an equal sign for that, so I'm going to put a fill dot. And this is going to be positive 2. Now I only want to draw the left side because it's less than equals, so it's just going up like that with basically a slope of 1 because I'm just drawing the left part of this function here. If I put in -2, missing the negative there in the question. If I put in -2 into this function here, remember we got to do the square first. -2 squared is +4. And then I have a negative sign here, so it's -4. Basically, it's down here. Should be an empty dot because there's no equals. And now we're going to draw the right side of this function, which is basically going to hit the origin and look like that. And this is just a value of -4. Again, these two functions are not touching. So this is going to be discontinuous at x equals -4.